All right, let's look at our last set of problems. These are going to be the most difficult, so the best thing that we can do is kind of plan this out. All right, so let's look at where we start and look at where we end. We're going to start in grams and we're going to end in liters. So we start at grams. We're going to end at liters. So we're going to use our mole map for this. In order for us to do this, let me do that. Okay, perfect. So we're going to start here, end here. So this is going to be a two-step problem. We go from grams to moles, so step 1, and then moles to liters, step 2. So grams to moles, moles to liters. So that's kind of our flow. So our plan is going to be from grams to moles to liters. All right, so let's make our chart. We have 200 grams of CH4. So our first step is to go from grams to moles. To go from grams to moles, we're going to follow our map here. 1 mole over grams with the mass. So we're going to do 1 mole over our molar mass in grams. So we got to find that molar mass. It's CH4. So carbon is 12.01. We have 4 times hydrogen, which is 1.01. So these two add together, we're going to get 16.04 grams per mole. So 16.04 is going to be our first one. All right, we check grams and grams cancel, and we've done the first part of our plan. So we've gone from grams to moles. So step 1 is done. All right, step 2, we're going to go from moles to liters. So we're going to start at moles and we're going to go to liters. So we follow this way, 22.4 liters over 1 mole. So again, moles and moles cancel, and we end up getting our answer here. So 200 divided by 16.04 times 22.4. So we're going to get our total of 279.30. So 279.30 liters. That's going to be our answer. So liters and liters match up. We got it. All right, let's look at the next one. We have atoms, and we're trying to find mass in grams. So we start at atoms. We're going to end in grams. So let's look at our plan. We're going to start at atoms. We're going to go from atoms to moles. And then, let's get info. No, that's not going to work. All right, whatever. We start with atoms, we go to moles, and we go from moles to grams. So 2 steps. All right, so first we're going to atoms to moles. So we follow the arrow, atoms to moles. We're going to use Avogadro's number. So atoms to moles to grams. So let's do that. We have 3.6 times 10 to the 23rd atoms. We're going to go from atoms to moles. So atoms to moles, we're going to use Avogadro's number. 1 mole on the top, and then 6.02 times 10 to the 23rd atoms on the bottom. So 1 mole, and then we have Avogadro's number. Atoms and atoms are going to cancel. And then we go to the next step. So we went from atoms to moles. Step 1 is done. Step 2, we're going to go from moles to grams. So moles to grams. Moles to grams, we're going to follow this one. Grams on top, 1 mole on the bottom. So grams on top, 1 mole on the bottom. Grams on top, 1 mole on the bottom. for this substance, we have iron, Fe. So Fe is going to be on our periodic table 55.85. So 55.85 grams for every 1 mole. So these cross out, and then we get our answer. So 33.6 times 10 to the 23rd, exponent 23, divided by Avogadro's number, times the number on top. So we divide this one, we multiply this one. So we're going to get a total of 33.40 grams. Sweet. So let's look at the last one. We start off with liters and we find molecules. So we're going from liters all the way to molecules. So step one, we're going to go from liters to moles. Then we're going to go from moles to molecules. So 2 steps. We start at 200 liters. We end at molecules. So our plan is to go liters to mole to molecule. All right, so let's set it up. We have 200 liters. So we're going to go from liters to moles. Liters to moles. I'm going to follow this one. 1 mole on top, Avogadro's number on the bottom. So liters to moles, 1 mole on top, Avogadro's number. Or sorry, not molar volume. So 1 mole over 22.4 liters. Liters are going to cancel out. So step 1, we're finished. Step 2, we're going to go moles to molecules. So moles to molecules, we start here and we're going to molecules. So we follow this path. Avogadro's number on top, 1 mole on the bottom. So 6.02 times 10 to the 23rd for 1 mole, and then you can get our answer. So we divide this one, we multiply this one. So 200 divided by 22.4 times Avogadro's number. So we get 5.38 times 10 to the 24th. And then molecules are our answer. So 5.38 times 10 to the 24th.